was going on yesterday, and I've been around long enough teaching where I can just look at my students and I can tell, whoa, they are wiped out. They're composites, inverses. And some of them have never seen composites. Some students have never seen inverses, how to deal with all this. So guys, we'll do this. First, I wrote myself a note or two here. Yeah, on composite functions, recap here. Of course, what we are thinking of as a composite is something like this. With a little circle in between, which means you're doing this. And Jonathan, I thought about you. When you do this composite, there could be some issues. You work with two functions, not just one function. Or just f of x, no problem. And where the issue may come in is what's the domain? And since you will be working with two functions here. The concern is the domain of that composite. That's what we were talking about yesterday. Let's see if I brought in an example before I go further here. Let me see. Oh, I will have it exactly for that. Also, in my recap here, we have, or I have, we had some discussion on this. An inverse function. And the notation was f superscript -1 of x. I think I pointed out yesterday that if that -1 was understood to be an exponent, it would be 1 over f, like a reciprocal. So it's a superscript. And I gave you a definition, somewhat of a definition on what to do here, interchanging coordinates. And we had a recap, I will recap, that the domain of the inverse should correspond with the range of the original. And the range of the inverse should correspond to the domain of the original. We talked about that. One thing I did not talk about, and an example coming up is, how does one check after they ask you to find the inverse? And by the way, first, before I ask you to find it, anyone remember yesterday with all that material? What's the requirement on the original function to have an inverse in the first place? Go for it.
Pass the vertical line test.
Nope.
Or horizontal, sorry.
Yep, it's got to pass the horizontal line test. In other words, it's got to be what? I used a phrase. 1 to 1. If the function's not 1 to 1, forget it. Okay, so the inverse function here, I'm on the side here, f of x, the original function, must be 1 to 1. You guys will write 1 to 1 like this. It's not 1 to 1, forget it. It does not have an inverse. Now, right quickly, since I mentioned that, before I go any further, please tell me if you saw this basic function here, x squared. Should I worry about trying to find an inverse for that function? No. It's not 1 to 1, it's a parabola. We're not past the horizontal line test, therefore you leave it. It has no inverse. If I saw this though, first we point out that this one has no inverse. But let's say my second example, I have a square root x. Is that a 1 to 1 function? Yeah, I can see what the square root x looks like as a graph. We passed the horizontal line test, so it should have an inverse. It's 1 to 1. Now, if it is a 1 to 1, let's find the inverse on this one. Easily done from yesterday. Interchange the coordinates. It's only 2 steps. Who recalls what to do after you interchange the x and y? What's the second step?
Solve for y.
Solve for y. So in this case, it looks like if you square both sides, you will end up with this. And I'm going to let that act as my inverse. This. Now I should place some restrictions here. Let's go back to the red. Guys, you know a square root graph. We've worked with that quite much. The domain on that red function, square root x, is 0 through infinity. be, you may want to visualize what a square root of x looks like on a grid. What's the range up and down on that graph? What's the range of the square root of x? Shake. Here again, I heard it. 0 to infinity again. It's all above the x-axis. Therefore, when I go down now, I ask you, here's what we're accepting for the inverse of the square root of x. I should point out on the side here, this blue, its domain is what?
0 through
0 through infinity. In fact, it should be, if I look back at the red, it should be the range. Is that true, guys? And that's what I think we were talking about. We had so much going on yesterday, though. I thought I'd better do a little recap here. So far, so good? Is some of this coming back to you? Making some sense? Now, with that said, letter C is coming up. I have to slow down a little bit here. I have not, I don't think in class, I don't think I had you to check. After you find the inverse, how can I do a true check to see, is it the inverse? And your textbook gives you a way to check this, and I like it. It does this. But before I jump into it, before I give you what they want you to do for a
So
check.
the domain of the inverse y equals x squared is 0 to infinity?
Yeah, the domain of this should be the range of this.
But it must be equal to greater than 0 then, right?
But
You
you
see
can
the,
put negative numbers in
do
it.
you expect the range?
And,
Hang on just a second. You said, well, should these two match up? Should the range of the original be the domain of the inverse?
Yes.
That's what we said yesterday. Now, Jonathan, I know what you're thinking, which I'm gonna do right now. Here's the way, Professor. I know if I visualize the graph of what's going on here, I think that's what you're thinking of. Let's sketch these. We sketch the ray graph first. Let me do this, make it reasonable. On the side here. Of course, when I have a marker, I need a marker to work. Bear with me, guys. Let's see, that's your grid. I hope you guys can see that, let me know. The red graph, this one. We know the red graph is this shape. Know exactly what you guys are thinking. You're a little bit ahead of me. That's the graph of square root x. We're saying now, this is acted as its inverse. Well, it's going to look a little odd if I graph this, and we'll graph it in blue. We know what it looks like, though. It looks like this. Is that true? Hang on. Is that true? Now, what did we say we were going to accept as the domain on my blue graph? It was the same as the range of the original. Is that the domain there? So that means I should do what here to make this look good, Jonathan, you're thinking about this. Only accept the part to the right of 0. So that means this is going to be wiped out. Because of that. That's why that was so important on this. I'm accepting only the part to the right of 0. Okay, guys, so that's the way the graph looks. Cute, very cute. So I've got the square root, and now also the f of x equals x squared, or f of x equals square root of x, and this was x squared down here. Now, what I want to point out, look how they overlap. I love the way these two overlap. The square root of x and the x squared. Can anyone tell me, what do you think is the intersection point of that blue and red graph? Just common sense. Don't go through some mathematical thing. Just look at it and tell me, what point do you think they share in common as an ordered pair? Or about I heard you say it, what was it?
1 v1.
It is 1, 1.
And 0 point.
At that point right there is what I'm concerned about. Yeah, 0, 0, of course. But that intersection point there Should it be 1, 1? Yeah, if you square 1, you get 1. If you take square root of 1, you get 1. Is that true, guys? So 1, 1 is shared by both those graphs. Now that said, you see, all these markers have been used. Let me see if this will work for me. I want to do this for a reason. We'll draw a line. If this marker will work for me, I want to draw a line that will go in a certain direction there. Maybe this is better. And then you guys give me a conclusion here. So the red, the blue, connected, let's say, there you go. Like that. If I accept that, look at that green line. Is the red graph maybe a reflection of the blue, or the blue is a reflection of the red across that line? What do you think, guys? So if I take one of those graphs, either the red or the blue, and reflect it across the line, do I get the other one? Is that true? Now, can anyone tell me, what do you think the name of, if extended, what do you think the name of this line I had in mind is? The y is equal to x. Thank you. Who was that? Michael? Who said that? There. Y is equal to x. Absolutely. She's right. So if I draw a function, draw its inverse, and then draw y is equal to x, you'll see a reflection from one to the other across that y is equal to x line. Now that will give me now a way to check algebraically an inverse. With that said, guys, there goes. That looks pretty good. To check this, your textbook suggests, and I can see why now, they suggest that you take the function, form a composite with its inverse with respect to x. And guess what you're supposed to get if you have the correct inverse? You're supposed to get x. Which has something to do with this. And the other way, if you put in the other direction, the inverse composed with the function of x is supposed to give you x. So that's a good way now, I see now a good way to check when you finally got a quiz on this. If you find the inverse, you think the inverse is correct, use that composite business. If you don't get x, you've made a mistake. Now we'll try one. We'll move on from there. So far, so good? Making sense? Jonathan, go for it.
The one that's f of in the inverse, and you put that in, then that's when I would domain change.
Well, it could. It depends on. Hang on. Yeah, I see
I
what you're saying. See it right here?
Yes, that right there with the domain.
Exactly. Exactly. We're going to try one here. I see what you're saying, Don. Hey guys, it makes sense that it should be x based on, like this. Like this, where you take the two and put them together with that y is equal to x line, it's a composite type. Okay, with that said, let me do this. Move to part 2. I brought in, thinking about you guys, not a square root, for goodness sakes. They're nice, but I have one like this. F of x is equal to 2x plus 1 over x minus 1, and another g of x is x plus 1 over x minus 2. Check to make sure all that's copied down correctly. It looks pretty good. I would like to find this. A composite of those two functions. Now they go back and identify, Jonathan, let's go back and identify the domain on each one of those first. the f has a domain of what?
X cannot equal one, and g of x cannot equal two.
X cannot be a one here, and down here, my domain on the G,
X can't be two.
absolutely.
No.
Now, if I want to find the composite, it means f of g of x. Which means do what? Put g of x, which is right here this. I gave you that, that's x plus one over x minus two. And you will take f of that over my thumb this one. So that's what it says to do. Ah, Nima, so that means go back to what, the f function? And replace all those x's up here with that expression. If I do, guys, it looks like this. 2 times, where was it? Oh, x plus 1 over x minus 2. 2 times that plus 1. All over, looks like x plus 1 over x minus 2 minus 1. I went back to my f function, did my replacement. Looks messy. Did I do it correctly? They got cleaned up. Your algebra skills want to be fairly strong to clean this up. Guys, to clean this up, I'm going to first rewrite this as, if you don't mind, 2x plus 2 over x minus 2 for that part. And then I got plus 1. I know eventually I need a common denominator. So let's write that plus 1 immediately for help as x minus 2 over x minus 2. That's 1. Now let's go to the denominator, clean that up. Not much to do here. We've got x plus 1 over x minus 2. And I need, again, a common denominator of x minus 2. So let's rewrite it as x minus 2 over x minus 2 for that 1 there. Everything's in terms of x minus 2. Put all this business together. Aiden, if I do this, can you tell the class what all this put together with that common denominator of x minus 2 is?
Sure, more or less. That's
Oh,
what I said.
whoa.
Wow. That together is 3x, just 3x over x minus 2.
Yeah, well, the 2's cancel.
Yes.
Tells me 2x plus x is 3x. I agree with him. Miriam, when I jump down to the bottom there and put all these together with a common denominator, I mean, this business, you gotta be careful. Can you tell the class what you think that will give you?
We have three.
Do it again.
3.
3. Merely 3. Oh, I'm good. You guys have been blessed. I'm good. Watch what's going to happen. If I clean that up further, definitely, no matter how you approach it, guys, I think you can see what's going to happen here. Will the x minus 2's cancel? Even if I set it up on the side there and do it, will the x minus 2's cancel? Will the 3's cancel? What's left?
X.
I got x. What's it mean? Got a composite, I got x. What might you tell me about those 2 functions I gave you at the beginning, these 2 functions? Thank you. They are inverses of one another. So when I checked it, and I got an x there, those 2 had no clue when I first started, but those 2 are inverses of one another. Jonathan, you see all this on the quiz or a test, I'm going to graph this. This is a rational function. Where would the vertical asymptote be if you were to graph f of x? Where's the vertical asymptote? Now I think my student read it for me. Mr. Stevenson read it for us. How do you find the, vertical asymptote? You set the denominator equal to 0, so what, you will get x equal to 1. That's the vertical for the f of x. If these are truly inverses, and looks like it checks that they are, then that 1, which was a vertical asymptote of this one, should turn into what? The horizontal of this one. Is the horizontal asymptote of this one, g of x, 1? It's 1 over 1, those coefficients. Mathematics. We'll try one more thing. Let's go back to the f of x. If I ask you to find the, let's say y-intercept. The y-intercept on the f of x. You say, Professor, just go back and replace x by 0. And you'll find the y-intercept, which I think you'll get -1. Now if I go down to here, what should that -1 play the part of down in the other function? There's the y-intercept on the f of x, what part should it play on the g of x? X-intercept. Everything's been switched, which it should, interchanged. That's what the inverse is all about. Nice, guys. Now, for the sake of you and me, in terms of time, I'm so happy when you see one of these being a quiz or an exam. If you check it in one direction, I'm happy. You're supposed to, though, officially, I checked in this direction. You're supposed to also check it. I'm going to use this. It's supposed to also work if you take it in this direction. G circle F. You're supposed to also get an X. It's supposed to work in both directions. Usually I have students just work in one. Have I been around long enough in mathematics where I've seen some work in one direction and not the other? Yes. It's not going to happen with us. You're not at Stanford yet. So it will probably satisfy with just one direction there. Yes, go ahead.
How soon are we gonna stumble into like those one-way composites, where like they only equate?
No, you're not going to see that here.
Okay.
I don't think the author gets expert through one yet. Okay. No, I'm talking about mathematics, maybe in grad school. Go for it.
And what would be the domain of f inverse?
Hang on just a second now. Oh, you're talking about this one right here?
That one in the past the one we just did with the x squared and the square root of x.
Oh, I got you, hang on. You're talking about this one?
Not that one, the one a little bit further back, that one right there, like that f of inverse there.
When I did this?
Yeah, it's still f of the inverse would be.
Oh, I got you. You're saying, hang on.
One would be.
So you're saying I don't think I tried this. You're saying maybe try it on these
Yeah.
two functions here? These two?
Yeah, with the inverse, like, so the f inverse of x squared, would that
Let's
still
do
be
it.
the
Let's do
domain
it.
of x squared?
John, let's do it.
I mean, x, third of x, or I mean,
I don't see. Let's do it.
talk.
It's a check. It's merely a check. Like I did a check on that one over there. You will need, before I leave this, Professor, find this
Yes.
and show me it better be X for an answer, because I think we classify these as inverses of one another. The
The
square root
domain
of
would
X.
be all real
Yeah,
numbers, or
exactly,
would it still,
exactly.
would it still
Well, no, we'll look
be
at
the
it.
domain of the original function?
We'll look at, we'll take f of the inverse. That's what it means to do, and I'll get an X. So that's f of, and I think the inverse we accepted as, what was it? X squared? And then let's go back to the original function, put in an x squared. I think the original function was a square root somewhere, wasn't it? Where was that? Or I did it backwards here.
f of x equals square root of x.
Yeah, square root of x, so we end up on square root of x squared. And will that could be an x? Caught up with the domain, you know the domain here, it has to be inside here, it's gotta be what, greater than or equal to 0.
But that always
That,
happens.
thank you, in this case it does.
And so the domain would be, you would neglect the domain for the inverse and just say all real numbers?
Yes,
But this is a special circumstance.
it is,
Okay.
it is. Guys, that help? I took a little time just to recap, my goodness, all these inverses and composites and domain and this and range of this. You gotta be careful. I hope this helped. Did it? Help somewhat? Guys, I think, let me check. I think that's all I wanted to say. Oh, no, yes it was, at least for the recap, and we're gonna start something else. We're in chapter 4, I'm trying to get this chapter 4 pretty much done today. Miriam,
Yes.
suppose again, if I leave all this, in my little recap, all of a sudden you see this given to you. And you know it's gonna graph into a parabola, vertically shifted up 4. And all of a sudden you see on the quiz or the exam, how are you gonna answer that question? Because I set it up to make it look pretty.
No inverse,
Thank you. No inverse.
pretty easy.
You just leave that blank on the test. Or just write out, no inverse, professor, and move on. Now what's gonna happen? I've had this happen in classes in the past. Mr. Park may have even done this when I had him. Rena may have done it. All of a sudden, you're sort of caught up with all this information. All of a sudden, you're taking a half sheet of paper or a sheet of paper. I'll say, are you not finished with your quiz yet? No, could you give me 10 more minutes? What are you working on? Yes. Professor, I interchanged the coordinates. You said interchange the x and the y. Solve for the y. I solved for the y. It's looking strange, but then I'm trying to list the domain of the inverse and the range of the inverse. And then all of a sudden, you walk outside there and your friend stands outside there waiting for you. What took you so long with that quiz? Man, that quiz was something else Ramsey gave. Had to find the inverse, the domain, the range. How'd you get out of class so fast? There's no inverse. There's no inverse. I quickly saw what he said, just put none. Move on. That's not a one-to-one function. So you gotta be very, very, very careful. I thought I would throw that in. Now guys, with all that said, I think it's a good recap. Let me go into part 3. Let me erase this. Now, do I have handouts? Of course I always have handouts. But let me just sort of lead into this. Mr. Park, you remember doing all this?
Mm-hmm.
Way back? Okay, part 3. Here we go. Getting close to the ending of chapter 4. I need a definition. Now, as if you do not have enough in terms of functions to remember. It's all about functions. Now, I've asked many times, why not call this class not math 2? Rename it functions. I think that's all you've been talking about this summer. Functions. Everything has function attached to it. Here comes another one. As if we don't have enough to worry about. Okay, here comes another one. And it's given a name, and its name is an exponential function. Oh boy, here comes another one. Johnson, along with it will be a domain. Along with it will be a range. They all have a domain and range. So I can do that also on this one. Now what does it look like? Thank goodness it's fairly basic. I'm going to give the definition like this. F of x is equal to a raised to the x. A raised to the x. Some textbooks, in fact, I think your textbook may have done this. Some textbooks will say, well, there could be a constant out front. So sometimes you'll see it written like this, with a c out front, c times a raised to the x. But there might be a constant out there. I'm more concerned about that a to the x itself. Guys, the a to the x, we identify first. This is like having a base, and a is the base, and x is the exponent. And therefore, they call this an exponential. You have an exponent to work with. On the side here, they do place a restriction on that base. They want the base to be positive, and please do not let a be 1. I wonder why they say ignore 1 for the base. You're taking a base and raising it to a power. Raise it to x. I wonder why they say don't mess with 1. Why not?
You just have C.
Yeah, what's 1 raised to any power? 1, that's too trivial. So they say don't use 1. And also use only positive numbers, a is greater than 0. And this x, raise it to a power. Now this x can be open. It can be an element of the real numbers. I can throw some numbers, any number of my choice up there. Guys, that's the way it looks as a definition. Now you know what's going to happen next. I got to see a graph of it. And then I got to look at the domain, the range, and then go from there. Guys, first, let me create one. F of x is equal to 2 raised to the x. I said let a be a positive number. I want you to choose a positive number for my first example. I'm going to use 2 raised to the x. That's an exponential. I'd like to see what the shape looks like. Is it a parabola? No. Is the graph a straight line? No. Is it a polynomial function, Professor, the max and min? No. It's a different shape altogether. And we'll graph it here in just a few seconds here. Before I do that, can someone tell me if, and it could happen. Suppose I had written this like this. Suppose I had placed a coefficient out front. 3 times 2 raised to the x. What's so tempting to do if there is a coefficient stuck out front that you can't do, but it's so tempting? Multiply them together and call it 6. Can't do it. Cannot do it. So you see a coefficient out front. Can anyone tell me what that coefficient of 3 in this case might be telling me? I can't multiply 3 times 2 and call something 6. What do you think that 3 might be telling me though?
Vertical stretch.
Thank you. When I graph this 2 raised to the x graph, this 3, if I throw a 3 in front, he says that's a vertical stretch by a factor of 3. Just stretches the graph. Okay. I'm more concerned about the basic graph 2 raised to the x for a reason. And here we go, guys. I want you to see what the sketch may look like. Some students may recognize it when I do it. Now I'm going to do it, hang on, with the help of a table. And in this table, x, y, I'm going to throw in a mix of numbers. Throw in a few negative numbers. Well, let's try those. We'll throw in 0 and a few positive. Form a table. Now I'm going to go back to my 2 raised to the x and replace x by those numbers. So this is 2 to the negative 2. We'll come back to it. 2 raised to a negative 1, come back to it. 2 raised to 0, come back to it. 2 to the first, 2 squared. Go back to the first one. What is 2 raised to a negative 2? 1/4. 1/4. 2 raised to a negative 1, 1/2. 2 raised to 0 is a blessing, 1. 2 raised to the first, another blessing, 2. 2 squared, 4. Now, if I plot those on a grid and connect, I should, with those few points, see the shape of 2 raised to the x, my first exponential function. When I grab it, gotta go inside here. See what this graph may look like. cover. And I'll plot this in blue, guys. My first point from the table is -2 up 1/4, barely above. -1 up a little higher, up to 1/2. We're going to place 1 on that y-axis for a reference. I'll need it. -1 up 1/2, a little higher. 0 goes up to 1. 1 goes up to 2, I think it was. Yep. Up here somewhere. And 2 goes up to 4, a little higher. Would you agree those points may look something like that, as I plot them from the table? Connected? Looks like, if I'm careful, the graph may do something like this. Is that the shape, maybe? For 2 raised to the x, f of x is equal to 2 raised to the x? Domain? From left to right, it looks like it's everything. Range, the up and down on this blue graph, looks like it's what? What's the up and down? Is it from 0 through infinity? And it looks like it's not including 0. This is not a rational function, but take a close look at it. Does it have an asymptote? There's a horizontal asymptote located at the x-axis. It will never touch the x-axis. And that's your first, I'm sure you've seen it before, look at an exponential function. How's that look? Okay, now they may say, now take this, and before I show you something else that's going to ask you to do with this, I have, if I brought it in, just to point out, beautiful. Ah, yes I did. I'm going to graph one more for you to see a relationship here going on. I like to sketch, I'm going to sketch on the same grid, guys, but on the side here, let me do this in red. Number 2, another function. Let's call it g of x. I would like to now sketch this. 1/2 raised to the x. And 1/2 is allowed to be used if you wish. I'm going to use a table for a reason. And go through. And guys, we're going to use the same numbers, a mix of numbers here I used earlier. Different graph though. I have 1/2 raised to a -2. I have 1/2 raised to a -1. And we'll come back to all these. 1/2 raised to a 0. 1/2 raised to the first. And 1/2 squared. Now let's go back and see what these answers are. Guys, 1/2 raised to a -2, what is that? 4. 1/2 raised to a -1? 2. Thank goodness 1/2 raised to the 0 is 1. 1/2 raised to the first is 1/2. And 1/2 squared, of course, is 1/4. Just a mix of numbers. Go back to the grid, place that in red on the same grid. -2 up 4. Well, -2 up 4 is going to start here somewhere. Next one says -1 up 2. And I'm just quickly say it's going to fall right in here somewhere. 0 goes up to 1. Oh, they share a point. And then 1 goes up to 1/2. When I plot it. And 2, even less, 1/4. Connect. I may get a graph that does something like this. And the red one represents 1/2 raised to the x. You agree? Now the blue, red graph, its domain also is this. Range, also this. And there's another exponential function. Okay, guys, I wonder, I want your help. Okay, I got these two graphs, I got the domain, the range of the two here. I'm not gonna graph this, but I need some input. H of x is equal to, let's say, 2 raised to a negative x. I'm not gonna form a table on this one. Okay, what you have anything about 2 raised to a negative x? That's another exponential, a little strange, but 2 raised to a negative x, can anyone tell me? Aiden, what about it?
1 over 2 to the power of x.
Do it again?
1 over 2 to the power of x.
He said, wait, Professor, that's the same as, for math here, 1/2 raised to the x. Is that true? And I've just graphed 1/2 raised to the x. And also I have on that graph there, the blue graph is 2 raised to the x. So I got this going on the blue one. And the red one, that I just finished up, was 1/2 raised to the x. And Aiden, you just told me that 2 raised to the negative x is the same as this. Do those two graphs have anything going on? Is there something, some relationship between the two graphs? And I might see it, and Miriam, help me out.
The reflection across the y-axis of each other.
Absolutely. You take one of those graphs and reflect it across the y-axis, you'll get the other graph. Okay, so you take the red reflected or the blue reflected, you'll turn that into the other graph, you can reflect it across the y-axis. Now, Aiden, tell me this. Number 4. Lead into something here. Suppose I gave you a function that looked like this. It's called j of x. And I had this out front. I had the negative sign out front. Where do you think I'm going?
I think you'd reflect it across the x-axis.
This is going to be reflected across the x-axis. That's the transformation. So I can go back to 2 raised to the x, my blue graph. I say, Professor, just quickly do this to it. Hang on, guys, let's see if the screen will work for me. And see if you guys will agree. Might it look something like that if I reflect the blue across the x-axis? That's true. So this is y is equal to negative sign out front, 2 raised to the x. Where do you think all this is headed? Something we've done before. Transformations. Transformations. So can I take an exponential and also perform a transformation on it? I can. And so I get a few hints already with these negative signs, reflections going on here. All right, guys, let's see, what else should I do? Okay, beautiful. Number 4. And then the most important thing is coming up here shortly. Number 4. I'd like to sketch marker this. And I think this will be enough on this for a while. Y is equal to negative, let's try 2 raised to a negative x plus 1 plus 4. Oh my goodness. And then we'll just stop at that. I see a sketch of it. I see the parent graph staring at me, the blue graph. I think the blue graph is the 2 raised to the x graph. That's the parent graph. So we're going to go through some transformations, and this is probably the only one I'll do. Can someone help me out? I'll identify the transformations as you do it, and I hope these markers hold up for me. I hope you use different colors. Can someone start me out with the negative sign out front? I think Aiden's already told us something about that. This is a what, reflection? Absolutely. Through the X. Now, someone in this clever class with all those good scores I saw last night. Can someone now tell me something I should be aware of up here? In terms of maybe coming up with another transformation. And before you tell me, I'll go ahead and tell you, and Danae is going to tell us here. When I go up here, I think I see two transformations. Aiden, go for it.
Don't you factor out the -1 from both negative x plus 1?
You're going to first, exactly, want that x completely by itself. So you're going to factor out a negative and rewrite that exponent like this. I have that x all by itself inside there. Now if I do that though, that negative sign that I just did that with, let's do this in green. This tells me there should be a reflection through what?
The y-axis.
Absolutely. Through the y-axis. The x subtract 1 that we created, if I do it in red, might tell me, with our knowledge of transformations, what? There's a horizontal shift to the right. As if that's not enough, I threw in a +4 on the end, which might indicate what else is going on. A vertical shift, what? Up core. And those are transformations. Now Miriam, if I'm patient, I need to put the paragraph on a grid and do all those transformations on it. And see what that final graph may look like, and then name its domain, its range, and all that business. Hey guys, these transformations get really crazy on you, so be careful. I gotta be careful. Okay, let's go to a grid. I want one where I can have some room. Let's try it up here. And reasonable. Okay, we'll accept that as my grid. And then we're going to start doing this business. First, guys, I'm going to place a quick sketch of my parent graph. That's that 2 raised to the x graph. And we know it goes through 1. Something like this. There's my parent graph. Now if I go and say reflect it through the x-axis, just so happens I have this in blue also. Guys, if I reflect this through the x-axis, do not let me make a mistake. Arena, she's going to do a much better job than I'm doing here. The first sketches. So this represents y is equal to negative out front, 2 raised to the x. Now in, let's talk about it, green. The green says now reflect that through the y-axis. So guys, if I take this result here and reflect it through the y-axis, please do not let me mess up. We're doing this in green. Does it look something like this? Labeled as at this point, y is equal to negative 2 raised to negative x. So far, so good? Wow. The red one. Red one says, now please be patient and take that green graph and horizontally shift it over to the right, in this case, 1 space. Shift it over horizontally to the right. I'm doing that in, looks like red. Guys, let's take that, show one here. And then we're taking, looks like at this point, I don't want to lose track where I am. I did the green one. We're taking the green one over 1 space to the right. Please tell me the best I can do. I'm doing it red here. Does that mean this point right here now is over here? One space to the right. Everything's supposed to be shifted over. Definitely this is here. Is anything else being moved? As I move things to the right, one space, I know this point right here is being moved over one. Is anything else being moved over just as I shift things over? Should I worry about anything going on there? Let me check, look at this. Or do I just have to make a rough sketch and pick up that one point? Okay, now if I get a y-intercept on this graph here, you have to replace x by 0. You can find the y-intercept maybe on the red graph for me, the graph I'm trying to get. Guys, if I do it just real quickly, what might that look like? Can I just connect in a sense like that? Or should it go closer up toward the x-axis? What do you think? You think it's going to come up like this and go closer to the x-axis like this? And I don't know, Jonathan, you were talking about maybe the y-intercept. Might that, is that red graph at least to the right of the green one? It's supposed to be 1 to the right. Does it look like at least it's to the right? Wow. Last thing to do is, if I can, down here in the black, vertically shift all that up forward. Now this is where it gets tricky. This is the last piece. If I shift it up forward, guys, Jonathan, yeah, if I knew that y-intercept, I could certainly shift it up forward, but I don't think I really need it at this point. I could find it though on the red graph. To shift that red graph up forward, guys, this point here can be shifted up forward for sure, right? I can shift that easily up forward. Now, tell me what else is being shifted up forward as I shift vertically up forward. I gotta be cautious about it. The horizontal asymptotes also move. So it's gonna go up to 4. Up here. You guys will do this, just so you see it. It's there. This point down here, guys, I guess is down at -1, shifted up 4. It's going to land at 3. I think this point's up 4. Is it going to land at 3 up here? Right in there somewhere. Yes or no? And it's going to take that same shape as, is it going to do something like this? Okay, here goes. Of course I miss it. It's going toward that horizontal asymptote there. Rough sketch, well, not too rough. It's this, and that's going to act as my final graph for all this, where was it? All this mess. That's a scrap. Now, I like that. How many of these can I do? That's it. I'll show you one here. And then we're going to list the domain and range. I've got a little concern before I leave it. The last graph is what, of course, I was seeking, and I did it through transformations. Jonathan, I heard you mention also something earlier. Let's do 5. If this graph is correct, and we think it is, and it's bounded by 4, because the horizontal asymptote was lifted up 4 also, so it's bounded by 4, so that won't get any higher than 4. Does it intersect, though, the x-axis? I'd like to know precisely where, before you leave the graph. Where does it intersect the x-axis? And also, does it intersect the y-axis? It looks like we thought, or my sketch looks like maybe a 2 there. I don't know, we're going to check and see. So before I leave it, on the side here, the x-intercept, let's find where it is. And guys, how do you find the x-intercept? You said the function equal to 0, and you got this. X plus 1. And then you sign out front. Plus 4. Set the function equal to 0 and try to solve it. If I try to solve it, let's move the 4 over. what happens? I'm gonna make this -4, -2, raised to this, plus 4. Yes or no? If I move the 4 over, are we okay at that point? What would you suggest next in the attempt to solve for x? Yes,
Why did you add that 4 at the second step? Shouldn't you erase that?
where was that?
And -4 equals -2 to the power.
Oh, right here, right here.
No, on the other side.
On the other
You
side here.
subtracted it.
Did I have a plus 4 here?
Or it's the other side.
Yeah, you moved it to the other
Yeah, you
side.
move it.
What, did I mess up here?
The
Oh, I
-4.
see, I see what you're saying, I see what you're saying, hang on. Jeez, trying to dump the board here. Let's set this function equal to 0. Now, make sure it's good, I see what you're saying, I think. We got this. And make sure, guys, I got this written like that. Set equal to 0. Now let's try to solve it. Move the 4 over.
Yeah.
She said, come on, Professor. Got this.
Yeah.
Is that true? Now what? Could I divide or multiply by a negative and get rid of those negatives? Now, if I do, could I change this into, which would be nice if I can I do that? Now, can anyone tell me now what's tempting to do, but you can't do it? First, what's tempting to do at this point? You're trying to solve this thing for x. I've had some students say, divide by 2. Divide both sides by 2. I don't think they're in math 7 right now, but they said divide by 2. What are you going to suggest? What can I do? 8?
Logarithms?
I see, it's leading up to logarithms. There's a word I haven't heard yet. Logarithms, that's my lesson's leading up to that sometime today. And chapter 4 is going to close with that. Yes?
Can we solve this problem as we can write for as 2 to the power of 2?
Nima, hang on. You say, Professor, let's be clever. Let's not go to logs yet. He says, rewrite 4, being clever, as 2 squared. And of course, the other side is still that. Now, the only possibility with his suggestion there, that those two sides could be equal, they have the same base, is for this to be equal to this. So guys, you want to set 2 equal to a negative x plus 1. Now I can solve that. Hey guys, I think when I solve x here, please help me out. Is it negative 1?
1.
Did I move things around? Is it negative 1? So it looks like, where's my final graph here? I've been doing so much here. This is supposed to be what here? Representing negative 1. On my black graph here, that's my x-intercept. The y-intercept, a little bit easier to find than the x. Y-intercept, all over the board here, is merely replace x by what? 0. So y is equal to, in this case, negative 2 raised to, here goes, what's it, negative it was, plus 1, and of course plus 4. Block that off so you can see it. Going back to my function, replacing x by 0, guys. I think it looks like that. Let's clean this up. This is y is equal to negative 2 raised to the first plus 4. Is it short of 2 as we thought it was? And there's my y-intercept as an ordered pair. Exponentials. And I'm going to leave it. I used a base 2 for my examples. You can have base 3. It says a. The base could be anything positive greater than 0. Now, a little story here about exponentials. I'll go back to my blue graph. This is shape of the graph, what it means. The last time I went into my bank to do some, talk with my person there. And talk about investments and all this, put my money here, my money there, careful, but everybody should be careful with their money, careful. So if you put something into like a savings account, you guys may have savings accounts, sometimes they'll say, we'll compound this. They love that word compound. We'll compound this semi-annually. In other words, every 6 months, we'll do something with your money, you get some interest on it. They don't pay much, but they do it semi-annually. Some banks, I'll say, well, do you do it monthly? Well, frankly, we might do it monthly. Yeah, so use that function, monthly. Could you do it daily? Oh, that sounds like, wow, I'm gonna put my money in this bank, if they do it daily, you'd find out, no, not daily. Now, if, can you imagine, if I went into the bank and I said, I'm a math professor, and there's a function out there that I would like you guys to program for my investment. Others may not have it, but I want it. What do you want, Randy? I want my money invested exponentially. They may not even know what that word means. Exponentially, yeah, I want my money to, like that. That's what this function's doing. That's what that function's doing. Rapidly growing, and they call it exponentially. So I like to put my money to, or my bank to do my money with an exponential function to take off. Guys, I think we have a good view of what an exponential function is. Now, hey, I heard you use a strange word.
Logarithms.
Logarithm. Before I get to the logarithm, we're going to do trig coming up soon. Talking about words, vocabulary. Some of you guys come from probably high schools where you probably had a trig course. And many high school teachers, and I understand why, but many high school teachers and middle school teachers, when they start teaching sine and cosine, remember all those words? We had a trig course, sine and cosine. They use, I didn't know anything about this little word they were using. Some of my students came in and said, oh, professor, I remember this in trig, when I started the trig chapter, which I'm gonna start with you guys soon. I said, what is it? SOHCAHTOA. I said, what? Have you guys heard of that? S for sine, and opposite, hypotenuse, and C for cosine, and they had a little, back in their high school, middle school, a way to remember the trig functions, which is cute, sine, cosine, and tangent, and I had never heard of it. Now I know it now. I thought they were calling me a name.
Oh, man.
What a class. Calling me names already. SOHCAHTOA. Okay, but I never heard of it, so that's coming up when we start the trig here. I want to just mention it. Since he mentioned the word what? Logarithm. Okay? Guys, with all that said, let me think what else we can do here. We're closing down chapter 4 pretty soon. Let me check. Oh, yes. Mr. Park, you're going to sort of close this down here. Here we go. I'm going to create a table for you. I've been doing tables today, Mr. Parker. You'll remember this. And I want to create this table in a special way, lead to something about an exponential function, which you might recognize when I do it, and then we're going to close this down. That is this. He's going to help me. So, Mr. Parker, do not make a mistake.
Okay.
Okay, other side here, because I want to do it fairly quickly. I want us, as a class, with his help, to look at a special exponential function coming up. I'm going to have an X column. Now my next column is going to look like this, and he's going to help me. One plus 1 over x raised to the x. Everybody sitting there thinking, where's the door? I gotta leave. That man's gone crazy. 1 plus 1 over x raised to the x. I'm gonna place some numbers in the X column first. I'm gonna place numbers for a reason that may look like this. Not gonna add more, but I think there'll be enough. Place large numbers for a reason. Now what Mr. Park's gonna do shortly for me, he's gonna take the time to replace on the right-hand side here, those X's with these X values that I have. And something's supposed to happen. Mr. Park, you ready for me?
Mm-hmm.
Okay, here we go. Don't you mess up. Okay, the first one, I'll say that, at least say that for you. I'm trying a 10 first. So replacing X by 10, and that strange expression looks like that. Mr. Park may, since he's using a device over there, he may want to put it in as this, might be easier. As 1.1, 1/10. Raised to the 10.
2
Carry it out to maybe 4 decimal places for me.
2.5937.
2.5937.
Yeah.
Beautiful. And he's doing the work for me. Now let's jump down to 100.
Mm-hmm.
Replace X by that strange expression by 100. Now let's let me go ahead and do it. Let's see what that mess is.
2.7048.
2.7048.
Yeah.
Beautiful. Now let's do it for 1,000.
2.7169.
2.7169.
69. Yeah.
Hang on. Now we're going to try it for 10,000.
2.71.
Oh, hang on, I'll write all this down. You're faster than I am. I'm writing. Tell me again.
2.7181.
81?
Yeah.
Okay, and let's try, let's stop with 100,000. Go ahead and put that 100,000 in there for me and see what on earth, hang on. Gotta get all this copied. What's that close to?
2.7182.
So the 3 decimal places is 2.718 again?
Mm-hmm.
These two are too close. You sure you didn't make a mistake?
No.
You sure?
Yeah.
Watch that, guys. Okay, 100,000. Could you put in 1 million for me?
Mm-hmm.
I'm concerned about those 2 last values you gave me there. They're so close to one another. How about 1 million? Put 1 million there for me.
2.7182.
2.718 again?
Yeah.
If you carried up to 3 decimal places, I think that 4th number may be a little different. Yeah. That's what this number I'm looking for is getting close to. It's getting close to 2.718. Some students may recognize what that number is an approximation of, and we identify in mathematics that number we're looking for as P. What's this value? It's close to, as Mr. Park did for me, to 3 decimal places. It's close to that. E is approximately 2.718 to 3 decimal places. Now, your textbook says E, that's its approximation, can be thought of as, here goes guys, you see these large numbers in my X column? I think everyone in class could say, Professor, that might be representing X is approaching infinity. You have large numbers in that X column. So a representation would be, we're trying to find a limit as x is approaching infinity, and certainly my x column is getting large, of this strange function, and we're going to call all that e. That's where e came from. That's roughly 2.718. Now, before we do take that break here coming up, I'm going to do it real quickly. Now, since I have a new expression to work with, e raised to the x, that's an exponential. That can be classified also as a raised to the x, and e raised to the x, that's an exponential. So if I say graph it, and your calculus instructor says graph it, we're going to do some calculus on it. So wait now, if I want to do a real quick sketch, without going through a table that I've been going through over there, yes, a quick sketch of e raised to the x might be what? In other words, what's the y-intercept on e raised to the x? Replace x by 0, what's e raised to the 0? 1. So I know it has a y-intercept at 1, and it's going to look something like this. Wait, Professor, I thought 2 raised to the x was something like that back here. It is. It is. This one varies just somewhat because this is what, 2.718. This was 2 here, raised to the x. This is 2.718 being raised to the x. So basically the same shape. So if they ask you to sketch y is equal to e raised to the x, that's it. Enough right there for your shape. And it's another graph of an exponential function. Guys, that's one more part of chapter 4 done. When we finally get to where I want to get, and I doubt I get to it today, chapter 5 is the start of the trig. Most students love trig. I love trig. Miss Park, you love trig?
Mm-hmm.
Serena, was trig your favorite part of math 2?
Yeah.
See? Yeah. So ask any student what was the best part of math 2. The A I got in the course. That's what many students, yeah, that's what they say. I see them later on, I said, did you enjoy that course? Did you enjoy math 2? What's the best part of it? I was looking for a particular topic. The A I got it. I said, oh, really? Really? I think we'll find the trig to be the best part. Okay, Aiden, we're going to take a break here shortly. Now, I'm going back to that word.